Hi everyone, today we're going to be dealing with two things related to angle bisectors in a triangle. First thing is, we're going to show that each internal angle bisector intersects with the external angle bisector of the other two angles. So you can see at the moment, we've got one internal angle bisector drawn in. So what we need to do is draw in the two external angles of the other angles and then draw in their angle bisectors. So we're going to just extend this line as such. There we go. And you should be able to clearly see the two external angles. I'm just going to draw them in for you to make it clear. There we go. And then we're going to construct the angle bisectors for each of these. Construct angle bisector. And you should be able to see already before we construct this that it is going to intersect with the other two angle bisectors. And there we go. So we can see clearly that those three angle bisectors, the one internal and the two other external, all do clearly intersect at one point. And let's just highlight that. The next thing then we're going to show is the point of intersection. This one we've just found is the center of the E-scribe circle of a triangle. Okay, now we found out what the inscribed circle was. It was the circle which is inside the triangle and it's tangent to each side of the triangle, i.e. touches them exactly once. So what is the definition of the E-scribe circle? Here we go. It says the definition of an E-scribe circle is a circle outside of the triangle that is tangent to one of its sides and tangent to the other two sides that have been extended. So again, tangent means that it just touches at one point. So what this is trying to say is that if we draw a circle, the circle should intersect with both this side here and this side here, and this side here at exactly one point. So we're actually saying that this point here is equidistant from those three sides that we've just mentioned, from here, here, and here. Now, if we think about that, that shouldn't be too hard to kind of prove. We know that this point is on this angle bisector, so it has to be equidistant from this side and this side. We also know that this point is on this angle bisector, so it must be equidistant from this side and this side. And similarly, it's also on this angle bisector, so it must be equidistant from those two sides. So I think just with that very simple logic, we can safely say that the perpendicular distance of this point to each of these three sides should be equal. I'm going to now draw in those perpendicular lines from the point to each side. And there we go. So just quickly using GSP, we've now got three perpendicular line segments. So what this means then is that, well, firstly we need to show that all of these have the same distance. So let's measure that. AB 2.7, super, let's move that over. Let's measure this one. We're looking for 2.7 again. Measure. There we go, 2.7. And then the final one, measure. And there we go, 2.7, which we're all certain should have happened because we're very safe in the knowledge that this point is equidistant from those three sides. And we can see that clearly with our lovely circle at the end. Okay, I think we're done for now.